Well, hello my dear champions, welcome back to our channel Deeksha Karnataka. Today I'm here in your Brahmastra 2.0 with the chapter probability. An important session, reason, simple concepts are there. We have independent events, we have conditional probability and Bayes theorem. Calculations are also very simple. Only challenge that we have to face here is every question is unique. Means every question that comes to you will be a word problem. You have to break it down in simple way and then apply your learnings. Don't worry about it. I'm going to deal with all types of questions in the session itself. So if you are here watching me, give me a thumbs up in the session. Always be subscribed to our channel, because if you are here preparing for your PU2 or KCET, this is the best way to do that. This is the best platform that can help you seriously get that outstanding score in both PU2 and KCET. So subscribe right now for more amazing classes like these. Okay, so let's start the session right now. So first thing, again, if you're somebody who are with us for a long time, understand that, good for you. But if you're somebody who's just starting, means you're still in that, curious phase of the preparation, means you're not sure what to do, you're confused about, you don't know how to deal with the entire syllabus of PU2 boards, and you know that PU2 board is very important for CET. You know, half of this, marks will be counted from PU2 boards, PCMB. Then take this course, Target 90 Plus PU2 crash course. What happens in this? Basically, what we're going to offer to all of you is one-shot lectures of all the chapters, starting with your highest weighted chapters. I mean, we won't go and learn all the chapters right now. We'll learn, first thing will be your high weighted chapters, where you can score the maximum amount of marks. Then you'll have PYQ lectures, you'll have lectures, notes and PDF given to you, you'll have live doubt solving sessions, you'll have dedicated WhatsApp community, and what else you have? Formula sheets. Subject offered will be very important here. The most important part is subject offered. You're getting physics, chemistry, maths, biology. Apart from that, you'll also get Kannada and CS. You'll also get Kannada and CS as part of this course, and of course you'll get the success blueprint test series that we had last year. The improved version of that, your PU2 dedicated test series, will come as the part of the course, all at a price of 999, only 1,000 rupees. We have fought with the management to get this price to be affordable for all of you, because we want all of you to go really good. Go and do really good in your PU2 boards. That is the first thing. We should do that. Okay, then only the KCET comes, right? First thing is getting good marks in PU2 boards. Okay, so take the crash course right now. The link for this course is given in the description. The course is already begun, but don't worry, you get the recorded lecture, and yes, you still have time to prepare for your pre-boards and your boards. Okay, let's start the session. So first we'll learn about the weightage. Check. The weightage is like this. We have 3 questions from 1 marker. Okay, this can be a fill in the blanks and MCQs. Then for 2 marker we have 1 question for 2 marks. 3 marker again we have 1 question. Total of 5 questions, carries 8 marks. Yes, the most the weird part, or something which is difficult in nature, even though the questions are MCQs or 1 marker, the question will be of a category that can be asked in the 2 marker and 3 marker also. Confusing? What I'm trying to say here is very simple. The question that comes for MCQs, that can also be asked, same question can be asked for 3 marker also, 2 marker also. That's how the level of questions are, even in the 1 marker side. That's unfair for us, because if it is 1 marker, the questions would be easy. It's not in the case of probability. You have to solve the big problems to get the 1 mark also in MCQs. Let's start solving the questions now. So check, in the session today I have brought for all of you 12 MCQs. As I said, MCQs are not just MCQs, they are equivalent to 2 mark and 3 mark questions. That's how the level is designed by your boards. And 13 to 20, your last 8 questions are 2 marker and 3 marker. So if you solve these many, you can clear all the concepts, all different types of concepts in your syllabus, and certainly you can score 8 out of 8 marks in your boards. Question number 1, that is MCQ. Let's solve this. A man is known to speak truth 3 out of 4 times. He throws a die and reports that it is a 6. Okay, means if I'm getting a 6, let's call the event to be E. I get 1 by 6. If you throw a die, total number of occurrences or event will be 1, 2, 3, 4, 5, 6. So total will be 6, and getting a 6 is 1 event, so 1 out of 6. Okay, not getting a 6 will be 5 by 6. Okay, and when he reports, what are they asking? That he reports it is 6. He reports it is 6, and he reports something, and it is what? 6 only, right? He reports something and it is 6 only. So what will that be? Let me check. He throws the dice and reports that it is a 6. Okay, he reports something and it is a 6. Correct, that's what they're asking us. So let's say he reports and he's saying the truth. Means he reports and he gets the 6. He's telling the truth, means 3 by 4. He reports and telling the truth means 3 by 4. Okay, and he reports and lying. Reports and lies, so not getting a 6. He reports it is a 6. Listen to me. He reports that it is a 6 but doesn't get a 6. That will be a lie. So you get 1 out of 4 times. Sir, confused here. Sir, confused here. Don't worry. I'll just take a moment to explain you again, because this question can be asked in 3 marker as well. So I will explain one more time. So listen to me carefully. He reports something and tells a truth, means whatever it says is a true. Okay, it's a truth statement, means he is reporting that you are getting a 6 and he's speaking truth, means 3 by 4 is the chances of that. Now whatever he speaks is a lie. What is the chance of that? 1 minus 3 by 4, which is 1 by 4. Okay, I'm looking for this statement. We can apply the Bayes theorem now. Remember Bayes theorem, very simple. Same thing is there, means we're gonna go with PRE into PE. What is this part, bacha? This part represents your conditional probability. Okay, you get here PR intersection E. Okay, this is nothing but PRE into PE. Okay, and the total probability will come over here. This will be total probability in the denominator, so we'll get both conditions of getting and not getting, means when it lies and when it speaks the truth. So PRE PE, same thing, and when it lies, so PRE dash and PE dash. Calculations, simple ones, check. So when he reports and gets it right, check here bacha, what we have. PRE is 3 by 4 into getting the event right, 1 by 6. Same thing will come over here, right? Very important question, can be asked for 3 mark as well. And when he reports and he lies, so 1 by 4 and 5 by 6, right? 5 by P dash is 5 by 6. Check here, 4 6 24, so we can cancel 4 6 4 6 4 6. You can take 24 common, right, in the denominator side, and we get 4 6 cancels. We have numerator as only 3 into 1, which is 3. Here we have 3 in the first term and 5 in second term. We have the answer as 3 by 8. Option C is correct. If you are confused how did I do the calculation, don't worry, stop the video right now and go and try your own calculation. You'll get the same result as 3 by 8. Answer is 3 by 8. Good question. Can be asked for 3 marks as well. A Bayes theorem. Let E and F be the event of a sample space S of an experiment. Okay. Sample space S, event E, event F. Event E, event F. Okay, they're asking us this value. We can apply what? Our conditional probability. Check. PE intersection F divided by PF plus PE dash intersection with F divided by PF. Take LCM. Okay, what we have over here? P intersection of E with F plus P intersection of E dash with F. Okay, got it? Think about it. E intersection with F is this one. This is your P of intersection of E with F. Clear? First part. So think about it. What is E intersection? E dash with F. What is E dash, bacha? So the E dash will be, E dash is everything but E, right? So this is my E dash. Everything but E, sir. Everything but E is this part, right? This is the condition of E dash. Everything but E. Intersection of that with F. Intersection of that with F. What is the answer? Simply this one, sir. Intersection of that with F will be this part, the red part. It means basically I'll end up with getting what? This area, this red part and the blue part. I'll get red part and blue part. Combine them, you'll end up with what? PF. Confused? Stay there. They are saying intersection of E dash. What is E dash? Whatever is not E. Whatever is not E means leave the E space empty. Everything will be not E. Let me show you over here. Not E means this, bacha. Not E means this one. This everything is not E. This whole thing is not E. And this is what? F. So if you take intersection of not E with F, what is the answer? This part right here. Now if you add this to the intersection that we had, what you will get? You will get PF. So this whole thing we are getting it as PF. PF by PF. What is that answer, bacha? 1. Probability is 1 means it represents the whole universe. Probability is 1 means represents the whole universe, and the universe is what? S. Answer is option C. A very logical, very beautifully designed problem. Okay, very beautiful design problem. It's a PYQ from March 2023. Okay, so I hope you got it. How I explained you is basically using the Venn diagrams, right? So not E, this is clear, right? This represents your intersection. This represents what? The everything space with only, okay, F in it. There's no E, okay, there's no E. Intersection, if you take the intersection of that with F, you'll get this strip, this F part, and that you combine or add with the intersection of E and F, you get the whole F. So PF by PF is 1, and that is nothing but probability of the sample space. I know I took time to solve this question, to explain this question, because I know even though many of you will get it right at once, but there are many students, thousands of students that will not understand this question that easily, and I'm here to help them as well, right? So it's okay if you don't understand in the first go, please watch it again. I've tried my best to explain you this problem. It is very good question. Number 3. PA equals to half of PB, which is 0. Okay, what is the value of, okay, PA is, excuse me, not wrong, I'm wrong, I read it wrong. P of A is bacha 1 by 2, P of B is 0, that was given in the question. They're asking us P of A slash B will be what? PA intersection B upon PB. Since PB is 0, this whole thing becomes infinity, so not defined. This is an easy question. This is an easy question. So that also comes, right? Let's move on. 4th. 2 balls are drawn at random with replacement. With replacement means the total will remain same. If you take something out and put it back, replaced, the total will remain same. From a box containing 10 black and 8 red balls, then the probability that first ball is black, okay, and second is red. So 2 chances, 2 draws are there. 2 draws. First is black and second is red. Black total is what? Check here. 10 black. So 10 out of 18. That is my first draw. If I have to pick the black, right? Black is given as 10 and the red ball is given as 8. I have to pick the black, means I'll pick from 10 out of the total 18. And the red is what? 8 out of 18. Simplify these. You'll get here 5, 9, 4, 9, 5 4s are 20, 9 9s are 81. Why multiplication, sir? Because I want both at the same time, right? It's an AND condition. It is AND condition, that's why multiplication. Answer is option A. Simple question. A very simple problem. Next. 5th one. 2 cards are drawn at random without replacement. Without replacement means this time the numbers will decrease from a pack of 52 cards. 2 cards are drawn means we'll draw 2 boxes. First we'll have what? Total of 52. Next we'll have what? 51, right? Because we've taken one of the card out and there are only 2 draws. First draw, second draw. What is this, sir? First draw means you're taking one of the card out. Okay, this is the second draw. When you draw the second card, it will be already reduced by 1. Total will be reduced by 1. Both cards are of the same color. Okay, so this will be what? Same color means I can have either red cards or black cards, right? Red is 26 and black is what? 26. So if I get black, I'll have what? I'll have 26 over here. If I get, let's say, 1 less, now it'll become 25. Any problem? No, sir. This is going to be what? 2. Multiply them. We have only 1 over here. 25 into 1 is 25. 51 into 2 is what? 102. Check. Check, please. Simple question. Okay, next. 6th one. 3 cards drawn successively without replacement. Superb. So 3 boxes without replacement, sir. Okay, and it will be all what? Multiplication, because they are all drawn at the same time, means AND condition. Okay, shuffle deck. First 2 cards are king. So first I'll have 52 cards here, then I'll have here 51 cards, I'll have here 50 cards. What is happening? First draw there were total cards, second draw 1 card is reduced, third draw 2 cards is reduced because we have without replacement case. Yeah, 52. Okay, 52. Check. I'm getting the first 2 cards are king and third card is an ace. So king How many kings I have, bacha? Total of 4 kings. And ace, how many I have? 4. So I get here 4 by 52. First one. Next, I have already taken 1 king out. I'll have what? Only 3 kings left. I'm not putting the card back. Okay, so 4 kings were in the beginning. Once you took the king out, you get only 1 king. Okay, 1 less king left, that is 3. And aces, how many aces are there? 4 aces. So write there 4. Simplify, you get 1 by 13 and you get 17, right? So 1 by 17 and you get here 2 by 25. So answer will be 2 upon 13, 17, 25. We can multiply. 13 into 17 is what? 13 sevens are 91, so carry is 9. 13 into 1 plus 9 is 22. 2 to 1 into 25. Okay, this value will be more than 500, I guess. Yeah, 5000 actually. So answer will be what? 2 upon. We have only 2 options of 2. This one and this one. Option A. How come, sir? Think about it. The last digit will be what? 5. 5 into 1, right? The unit digit is 5. So means I cannot cancel the 2 with the number because it is an odd number in the denominator. First clue. Second clue, 25 into 200, 5000. So of course it will be more than 5000, hence the answer is option A. Second option has less than 5000. Getting it? Don't multiply, just get the result. Next, 7th one. A die is tossed thrice. Okay, a probability of getting an odd number at least once. So I want odd number at least once, right? Odd number at least once. It means what is it? 1 odd, or I want 2 odds, or I want 3 odds. We have 3 spaces over here. Please check 3 boxes. Box 1, box 2, box 3. Box 1, box 2, box 3. In one of the setup, what is the chance of getting? How many are there, bacha? We have total odd will be, odds are 1, 3 and 5. And total is what? Total is what? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Means getting the odd is what? Probability of getting the odd is 1 by 2. Probability of getting the even is also 1 by 2. This is clear, right? Basic understanding of how the die is tossed to get odd and even is clear. Okay. I want at least 1 means more than 1. 1 and more than 1. So 1, 2 and 3. But not 0. Means probability of getting at least 1 odd. At least 1, right? At least 1 odd will be equal to 1 minus probability of getting what? 0 odds. Correct, no? Means probability of getting 0 odd will be a case, right? We'll have a case where it is probability of what? 0 odd. Think about it. What is that going to be? Only one case like that. 0 odd means what? All is even. 0 odd means all is even. Means it can be 2, 2, 2 like that. Yes or no? Yes. So probability of getting all odd. Sorry, or 0 odd. Probability of getting 0 odd means what? All even. 1 minus probability of getting all even. I'll explain this step again. I'm looking for probability of at least 1 odd. At least 1 odd. Okay. At least 1 odd means 1 odd, 2 odd and 3 odd. This basically means that probability of getting at least 1 odd means that 1 minus, total probability is 1 minus getting the, remove the basically 0 odd case. Remove the basically, see here, 1 odd, 2 odd, 3 odd. What is the remaining case? The 0 odd. Right? No, we have 3 boxes. I can get 1 odd, 2 odd or 3 odd numbers, or I can get none of them as odd number, all evens, right? So 0 odd means what is it? All even. I can change some spellings over here. This is 1 and this is 0. Okay, I can rewrite this. Check here. This is at least 1 odd. Okay, and this here is 0 odd. To have less confusion about this. Okay, probability of getting 0 odd you can remove. 0 odd means what? All even. 0 odd means all even. What is the answer for all even? Check here. Means I want the spaces that we have to get even numbers only. For the first one, 3 by 6, 3 by 6, 3 by 6. What is it? 1 by 2, 1 by 2, 1 by 2. What is the answer? 1 by 8. What is the answer over here? 1 minus 1 by 8. Answer is 7 by 8. Option B. Sir, you took too much time to explain this question. As I said, can be asked in 2 marker also. Can be asked in 3 marker also. Okay, that's why I've took some time over here. So I hope you got the concept behind it, because I understand many of you I've seen students, I've taken a lot of classes, and many of you struggle in the concept side, problem side of your chapter probability, and it has 8 marks with simple calculations. So I'm here to help you in that. Question number 8 now. If A and B are any two events such that PA plus PB minus PA intersection B, they've given that PA plus PB minus P of A intersection B is PA. PA cancels, so I'm getting this as PB equals to P of A intersection B, right? Check here. So I'll get what? P of A intersection B upon PB equals to 1. This is the formula of conditional probability of A slash B. Yes or no? What did I do? Simplified this, cancelled, moved on the other side, divided by PB is 1. Here we get PA conditional B with, okay, is 1. So option B. Yeah. Question number 9 now. Question number 9 now. If A and B are two events such that PA is non-zero, PBA is 1. PBA means B intersection with A upon PA equals to 1. Cross multiply, PB intersection A equals to PA. Listen to me. Draw the Venn diagram. Here is B and here is A. How come, sir? Intersection of A and B is A. Listen to me. Intersection of A and B is A. Intersection of A, this small one, and the B is A. It's true, sir. This is correct. This is right, sir. It means actually A is the subset of B. A is contained in B or subset of B. Answer is option A. Didn't I tell you that I will cover up everything which is there in your syllabus with these questions that I've taken today? These are the PYQs and the most expected questions for your preparation of chapter probability. Next, 10th one. The probability of solving a specific problem independently by A and B are 1 by 2, 1 by 3 respectively. If both try to solve the problem independently and the problem probability is solved, okay? Anything else is given? They're saying they're both trying to solve the question and it is solved. So A union B, right? So PA plus PB minus P of A intersection B. Listen to me. What are they saying? They both try and they are ending up solving the question, okay? What is the probability of that? Check here. This answer will be 1 by 2, 1 by 3 and minus independent events, right? They are independent events. It means product of those two. 1 by 2 into 1 by 3. LCM will be 6 here. 2 3s are, so 3. 3 2s are, so 2 and minus 1. 3 plus 2 is 4. 5 minus 1 is 4. Answer becomes 2 by 3. Option B. Option is B. Listen to me. They're saying both try to solve it together, okay, and they get the result done. Okay, what is the union? Independent means union. Okay, union we take PA plus PB minus PA intersection B. Remove that statement. Since they are independent events, I can multiply to get the result. PA into PB, 1 by 2 into 1 by 3 is 1 by 6. Take the LCM of all of that, you get the answer as 4 by 6. Hence 2 by 3. Option B is correct. Same question. In this case, exactly one of them solves it. What it means? A solves, B does not solve, plus A does not solve and B solves it. Right? Okay. Good, sir. Think about it. A, B. A solves but B does not solve. Listen to me. A solves but B does not solve. Only this, sir. This is your first condition. And how do we write this? So from P of A, remove P of A intersection B. Please check. Please check. A solves, B does not solve is this shaded part. That is nothing but from P of A, remove the intersection part. What about this, sir? What about this right here? A does not solve and B solves. A does not solve, only B solves. What is it? Nothing but, check here, from B, remove the intersection. From B, remove the intersection, you get only B. Okay, this is only A, this is only A, and this is what? Only B. Your way of writing it. Okay, take here, you get P of A plus P of B minus twice of P of A intersection B. This and this becomes 2 times. P of A is what? 1 by 2. P of B is what? 1 by 3 minus 2 times of product of those two is 1 by 6. They are independent events. Question was same. They are independent events. Cancel this. 1 by 3. So 1 by 2 plus 1 by 3 minus 1 by 3. What is the answer? 1 by 2. Answer is 1 by 2 D. Good question or not? So the question that I've taken can be asked in 2 marker and 3 marker. So be ready for that. Every question is important in this session. Next one. This is your partition of sample space. E1, E2, En. Okay. Partition sample space. I hope you remember this. How we create partition? First partition, second partition, third partition, and so on. And so on. So, and so on. What is the understanding of this? That if you add all of these, you'll end up with what? If you add all of this, you'll end up with the whole union. Okay, the whole union or 1. Okay, if you add E1, E2, E3, you'll end up with union, or basically in this case probability of the union, which is 1. Okay, confusing sir. Let's not have any of those. If I'm adding, okay, if I'm adding like this, let's say I'm adding E1, E2, so on all the way till En, I get union only. And if I take probability, it will be 1. What it means? It means exhaustive in nature. Exhaustive. If you take all together means collectively exhaustive in nature. Collectively exhaustive. All the partitions are collectively exhaustive in nature. Means when you add up, it becomes union, or take probability, it becomes 1. And they're also mutually exclusive. What it means, it's mutually exclusive, means there's no intersection. Intersection of E1 with E2 is what? 0 or null set. We have 2 conditions to define a partition. First condition was this one. Second condition is over here. Collectively exhaustive means when you add all the events, it becomes the whole, and mutually exclusive means nothing in common. So E1 intersection with E2, or any case you take, will be phi. Check the question now. They are asking what? EI intersection with EJ is equal to phi. It means the I has to be not equal to J. Check here, this is 1 and 2. This will be 0 only when the partition will be different. Okay. So whenever the I and J are different means the partition is different. The partition is different. Okay. In that case, what will happen? It will be a null result. Okay. Nothing in common. So answer is, option B. Answer is option B. So this is the end of your 12 MCQs, or 12 very good questions in the chapter probability. Next, 2-3 markers. PYQ from 2023 paper. If A and B are 2 events such that PA is 1 by 4, PB is 1 by 2, and PA intersection B is 1 by 8, they are asking us not A means A dash intersection with B dash. Okay. Whenever you see dash, no, use this. Whenever you see dash, use this. This is A and this is B. Not A dash means what, bacha? Not A dash means everything over here. Everything is not A dash. Not A dash basically means only B, right? And the whole. Check here. This is not A dash. This is not A dash. And not B dash is what? Sorry, not B is, not A is this red one, not B. Not B. Okay, not B dash actually, not B. Not B will be everything what? Everything but, what do you call? This one. So we'll have everything over here. I can draw it, okay? I can draw it separately. So we'll have this, and this is your A and B. I'm looking for B dash. It becomes all of this and only A. The same intersection of those two. Intersection of those two. Check. You'll have the result as intersection of those two will be what? Only. So only the outside part. There's nothing over here. Only the outside part. What it means? It means 1 minus P A union. Sorry. 1 minus P A union B. Makes sense or not? Please check. Right? This means 1 minus P A union B. This is A union B. So from whole is what? PU. What is PU? 1. So from PU remove the union of A and B. Check here. P of A 1 by 4. P of B 1 by 2 minus 1 by 8. Change the signs. You will have LCM is 8. Here you will have 8 minus 2 minus 4 plus 1. Correct, no? Check here. This is minus, this is minus, this is plus. So 4 2s means 2, 2 4s means 2, again 2 4s are right. So 1 4s is 4, correct, and 8 1s means 1 1. So 9 minus 6, so 3. This is your answer. 3 by 8 is your final answer. Please check. 2 marker. Question number 14. You want to check one more time? Question number 14 now. Bayes theorem question. Very simple. Of the student, how do you solve this question? So first you see what they have given. This is the first two statement, and then you check the last statement. Then you check the last statement. Okay. Of the students in the college, it is known that 60% of them reside in a hostel. Means probability of picking a student and his hostler will be what? 60 by 100. So 6 by 10. Wait. Probability of picking a student and he is a hostler is what? 60%. So 60 by 100. So 6 by 10. And a day scholar is what? Day scholar will be what is it? 40%. So 4 by 10. Okay. Now forget about everything else. What are they asking? One student is chosen at random from the college and he has A grade. Means you have already chosen a student. He has the grade A. He has the grade A. Excuse me. Very important. Now they're saying that you want the student to be a hostler. So H. You're looking for this statement. Looking for this statement. Find what they're asking. And then you can just simply find the later remaining values. A, H, A. This is I've taken as S, right? I've taken as S. No problem. Check here. A student who is a hostler and what do you call? Getting that A grade. What is that? Hostler and A grade? 30%. So 3 by 10. 30%, so 3 by 10. And who's a day scholar and gets 20% as A grade will be your 2 by 10. Applies the Bayes theorem now. We're looking for PHA. This is nothing but PAH into PH. What is it? A student who's a hostler and gets a A grade and divide by total probability. So this is nothing. What is this, bacha? This is nothing but. What is this? The numerator comes from the conditional probability. Okay. PAH into PH comes from this one. Okay. Now what is this? Divided by total probability. So you'll have here. Please check. Excuse me. PAH into PH. The first one repeats. And PAS into PS. You have the values. So write it down. Right. Check here. So we have AH as 3 by 10 into getting the hostler 6 by 10 divided by same thing 3 by 10 6 by 10 plus here we have PAS 2 by 10 and this we have 4 by 10. Check. So I can cancel over here something. Yes, 10 10 10 10 10 10 is cancelled. Take 100 common and cancel in both sides. Okay, I get 18 in the numerator. Over here I get 18 plus 202. So 18 plus what is this? 8 plus 8 is 16. So 26. Simplify. 9 by 13 is the final answer. 9 by 13 is the final answer. Can a question get easier than this? This is the word problem. Students get scared of this kind of question, Bayes theorem. What did I tell you? Simply find the first two statements, values, and check what are they asking. From there everything becomes reversed and easy. Next, have a look one more time. Question number 15 now. The probability of obtaining no head appears when two coins are tossed. No head means both tails, so 1 by 4. When two coins are tossed, we have total of will be what? 4 chances or 4 outcomes. How do we know that, sir? Formula is m to n. What does m represents? Number of outcomes in one event. And what is n represents? Number of events. Check here. You're tossing a coin means you have 2 chances. And what? How many coins you're tossing? You're tossing 2 coins. So 2, answer is what? 4. So total is 4, and you want a case with no heads, means both tails. So this is the case. Hence the required probability is what? 1 by 4. This is your answer. 2 marker. Can be asked in, this is the simplest question in all of the questions that we have solved so far. Can be asked in 2 marker or in MCQs. Okay. It's a PYQ. 16. Another question, I think on the Bayes theorem. Have a look. Bag 1 contains 3 red, 4 black balls. So B1 has 3 red, 4 blacks, and B2 has 5 reds and 6 blacks. The probability of picking the bag 1 and bag 2, since they are not rigged, will be 1 by 2. There are 2 bags. Chances of me picking one will be what? Half a chance. There are 2 bags. Chances of me picking one of them will be what? Half a chance. So 1 by 2. Okay. Now let's look at the question statement. What are they asking? One ball is drawn at random from one of the bags and it is found to be red. We have got the ball to be red first of all. Okay. Now I want the red ball from bag 2. Question statement. That's what they're asking. So find the other cases. Red from the bag 1 will be what? Red from bag 1. 3 by 7. Probability of getting a red. Excuse me. Probability of getting a red from bag 2. What is that? 5 by 11. This is 5, right? So 5 by 11. Got it? Now let's apply the Bayes theorem. I'm looking for, what is it? Red from the bag 2. What I'll have? P, same thing, R, B2 into P, B2. This we get from the conditional probability. And we have same thing. PR, B2, PB2 plus probability of, one second, PRB1 into PB1. Check the values now. 5 by 11 into 1 by 2 divided by, same thing, 5 by 11, 1 by 2 plus 3 by 7 and 1 by 2, because PB1 and PB2 is both 1 by 2 only. Okay, calculations now. 1 by 2, 1 by 2, 1 by 2 is cancelled. What I have left? 5 by 11 divided by 5 by 11 plus 3 by 7. Add them. 5 by 11 in the numerator. Take the LCM over here, we get 77. And we get here 5 into 7, so 35. And 3 into 11 is 33. I'm getting here 5 by 11 divided by 68 by 77. Looks difficult? It is not. Check here. 11 times 7 is 77. I get what? 5 upon 68 by 7. 7 goes up. So we have 35 by 68. That's the final answer, please. Be careful and check. Okay, sir. Bayes theorem question. So I have taken all the different types of questions that will that are from the syllabus. Okay. PA is this, PB is this. This is very easy. PA intersection B by PB. 0.2, right? by 0.3. Answer is what? 2 by 3. That's it. 2 marker. Right? Correct? Yeah. Next. A fair coin and an unbiased die. Tossed. Coin can give me head or tail. Die can give me 1 to 6. Head appears on the coin. Okay, head appears. Probability of getting the head will be what? 1 by 2. Probability of getting what? 3 on this will be what? 1 by 6. Correct? No. The total of how many occurrences when you throw a die? You get 6 occurrences. 1, 2, 3, 4, 5, 6. You're getting a 3 means chances are 1 by 6. Okay. They're looking for independent. Try this out. What is the meaning of A intersection B? It means I should get H and 3. Right? H and 1, H and 2 like that. H and 1 till H and 6. 1 occurrences. H and 1, T1 till T6. Correct, na? Check here. We have H1, H2. Excuse me. Let me write it better. So we can have here H1, H2 till H6, and we have here T1 till T6. Total of 12 probabilities are there. And we want only H3, which is only one case. So what is the answer? 1 by 12. I should not have repeated this. Not required. Yeah. What is the answer? 1 by 12. Multiply these two. P of H into P of 3. So 1 by 2 into 1 by 6. What is the answer? 1 by 12, which is nothing but P of A intersection B. Hence, A and B are independent events. Independent events. Got it? Okay, last two questions. 19th. A bag contains 4 red and 4 blacks. Okay. Bag 2 is also there. So bag 1 is 4 red and 4 black. Bag 2 is also there. Okay. 2 reds and 6 blacks. Picking the bag will be what? Random. So PB1 equals to PB2 equals to 1 by 2. Picking the first bag or second bag will be what? Half chances. So 1 by 2. Okay. And a ball is drawn from the bag which is found to be red. Okay. Means we have got a red ball. We want it to be from the first bag. So B1. This is the question statement. Okay. Let's try. R B1 will be what? Red of the bag 1. 4 by 4. So 1 by 2. 4 by 4. 4 by 8. No. 4 reds, 4 blacks. So 1 by 2. P of red from the bag B2. What is that? 2 by 6. How much is that? 1 by 3. Bayes theorem. So PB1 R will be PR B1 into PB1 divided by PR B1 into PB1 plus PR B2 into PB2, the total probability. RB1 is what? 1 by 2 and PB1 is again 1 by 2. So 1 by 2 into 1 by 2. Over here we have same thing 1 by 4 plus, I can do better, 1 by 2, 1 by 2 plus PRB2, 1 by 3 and 1 by 2. Please cross check. 1 by 2, 1 by 2, 1 by 2 is cancelled. So I have here only 1 by 2 left in the numerator. And over here we have 1 by 2 plus 1 by 3. 1 by 2 is over there. LCM you take, we'll have LCM is 6. And we have here 3 plus 2. Okay. 2 and this will cancel with 3. I have 1 upon 5 upon 3. Answer is what? 3 upon 5. This is what? Pick the red ball from the bag 1. Pick the red ball from the bag 1. Check. Okay. Next. PAB, they ask us to find. This simple question, 2 marker. PA intersection B upon PB. There's no challenge over here. 0.32 by 0.5. 1, 2. Cancel. 32 upon 5 into 10. 5 6 is what is it? 30. 0.5 for the 20 by 10. So 0.64 is the answer. Okay, that's your answer. This is the end of your session. The questions on your probability chapter, the most expected, and the PYQs. Okay. So thank you all for joining in. If you have not subscribed the channel of our Deeksha Karnataka, subscribe right now. We have more amazing classes like this coming up on our channel to help you prepare for your PU2 boards and KCET. Okay. Any other doubt you have to ask me, leave that in the comment section. If you have still not joined our WhatsApp community, the link for that is given in the description of this particular video. Go and check that out and join the WhatsApp community for all the updates regarding exams and the upcoming sessions, whether it is live or recorded. So that's all for today. I'll see you again very soon. Till then, take care. Bye-bye.